So, alright everyone, so in this section we are going to start on one of the most important pattern in the data structure and algorithm, that is two-pointer technique. So before we jump into some coding or some problem, I want to set the right mindset. So most probably in the interviews you might have feel that, also you have seen, if you are giving the interviews you might have faced that problems are rarely repeated, but the patterns are repeated again and again. So my focus here is to understand the pattern first. So instead of memorizing the solution, our goal is to understand how to think, and two pointer is one of the first thinking tools that you must need to understand. Okay, so and also very important, two pointers is not just a coding trick, it's a way to control how to move through data. There are multiple data as well. Now how do you are going to move from this data to this data, this data to this data, or this data to this data? There are multiple ways to move. So it control how you should move. So based on this pattern of problem, it's give a way to think like how to move the data from one place to another place. Okay, so let's give you one idea on this. Suppose I'm having one array, something 273, any number you can take. Okay, so like we are talking about the two arrays. So normally what we do, if I want to move from one data to another data, we are going to use one loop, right? Simply loop, like maybe for loop or while loop, and one pointer will be here, and we just scan from left to right. So this is the left and this is right. So we normally do this. Okay, this is the pointer 1, and we keep on moving this, right? And it normally works, but sometimes this is not enough. We need more control. So instead of using just one pointer, we may require two positions. It means two positions means two pointers, one on the left side, one on the right side. Okay, so the question might come, why not single pointer? Okay, so let's take one example of, suppose one problem. I'm going to take one problem to make it understand. Okay, so this is one array which is having some zeros and having some non-zeros number. Okay, so now imagine a problem like this. I want to process this array, and if I use only one pointer, what I can do, I just scan this. I can rate it in one go, this element, then this element, then this element, then this element, then this element. But I don't know where to place this element, right? I don't know, like if I'm at this place, I don't know whether this zero moved to here or this zero moved to here. So I'm not going to, I'm not able to solve my problem because I don't have any control on the movement of the data. Okay, so to control the movement of the data properly, I need another pointer. Okay, so that is called two pointers. So here I will introduce two pointers now. So one pointer, suppose one PTR I am writing, one pointer, let's call it left, and another pointer, let's call it right. So one pointer is going to scan the array, and another pointer is going to decide where we have to place that element or where this element should go. Okay, so if you feel, I have a control, I am scanning, I have a control. What I have to do with this scanning data, where I have to place, I have that control also. So suddenly you realize I have a control. Okay, so one pointer is observing and other pointer is controlling. Observing is scanning and other pointer is controlling those part, movement control, right? So hope this makes sense. Okay, so let me roughly summarize this. So two pointers technique means using two position in the data. So using two position in the data to control the movement, comparison or transformation in an optimized way, right? So two pointers to understand. Now there are multiple types of two pointer, not multiple types, only two types of pointers. Okay, if both pointer ptr1 and ptr2 are moving in the same direction, this is quite possible, right? And another case is that when your ptr1 and ptr2 are moving in opposite direction, correct? All right, so first type, when both pointers moving in the same directions, this is used when we are going to rearranging the data. I'm just typing on very general terms, so later we'll go more bit in deeper side. So, and we'll try to understand like how this words is going to give a clue, okay, what kind of pattern you can think of. Okay, so this is the rearranging problems or scanning and placing the element. Okay, not only scanning and placing here means some transformation, some processing we're going to do. Okay, second is opposite one. So in opposite, what happens, suppose I'm having 1 2 3 4 5 6, so this is my left pointer and this is my right pointer. So this is and this right pointer is moving in this direction, this left pointer is moving in opposite direction. Okay, so you just based on the diagram you can think of pointers start from opposite ends, and we are going to use this for pair problem. Like, okay, find out two elements which is having the sum of this number, okay, which is having a sum of x. Okay, so pair problem we call it. Then we are having some sorted array problem, and palindrome is one of the very frequently asked questions. So palindrome problem. Okay, so palindrome means you might be knowing like, okay, so 1 2 3 2 1, so this is a palindrome. So what you are going to check, like left, this is right, so you're going to do some operations. Okay, so we'll see this. So this is kind of problem where we can use this. Okay, second, in the same direction there are multiple variations. You are moving in the same speed, we are moving in the different speed. Okay, so this is the, like, I can think like we normally call it fast and slow pointer. Okay, so I mean one moves faster than other, so this is used in in cycle detection. Like, okay, in there is your round circle, if there are two person, one person moving with x speed and another person is moving to y speed or 2x speed, then there will be some points when they will meet in this point. So that meeting if happening, then we can think of there must be a cycle in this whole array. Okay, so it is used in cycle detection. Very famous problem is I will see this in a multiple data type also. Cycle detection, and this is used actually with the linked list, and finding middle element. Okay, finding middle element. So very important point you should note, two pointers is not about the pointers. Don't think some pointer, some something. No, it's about controlling the movement in the data. So these are the two positions. When I'm saying two pointers, means we are going to talk about the two positions. Okay, so the question is, how do we know that when to use this, right? I mean, how, looking at the problem, it's going to give me the signal, okay, hey Ravi, now you can use this, two pointers here. How? So some signals I'm going to, some hints, I'm going to talk about. You have to think it's not a very specific thing. it's a very broad thing, but you have to somehow converse those problems into this particular categories. So like in place modification, I mean pair I talked about, right? Pair or comparison. Third is like partitioning. Partitioning means there is one array, multiple kind of like 1 2 3, then 0, then 5, then 0, then 6. So someone will say, okay, can you categorize the 0 together and non-zeros together? Okay, so this kind of problem, partitions. Okay, and some sorted array also we are going to use this technique. So let me write this also, sorted array. So whenever you see these signals, your brain should automatically think, can I solve this using the 2 pointers? Just give a thought on this. Okay, so let me talk about some common mistakes also. So now one mistake a student or any interviewer going to make it, like when they are trying to force 2 pointers in every problem. This is wrong. Every pattern is made for some specific type of problem to be solved. Okay, so remember, one technique cannot solve all the problem. This is completely wrong, and pattern should emerge from the problem, not to be forced on it, right? So by looking at the problem, you have to derive your patterns. Okay, so now we understand the idea, right? But understanding theory is not enough. We need to see how this pattern actually emerges from the problem. Okay, so in the next part, we will take our first problem, easy problem, and we will not directly apply 2 pointers. We will first understand the problem, then brute force it, means some naive technique we are going to use, then we'll discover the pattern step by step. Okay, so and remember this, if you don't see the pattern immediately, then that's completely fine. It happens. Our goal is not to recognize the pattern. Our goal is to derive them. Okay, so maybe that particular pattern is you're not going to it's not going to click immediately. Okay, then solve this, the naive problem. So when you are going to discuss the naive problem with the interviewer, I am sure that this problem could be solved from 2 pointers, it's just going to hit your mind. Okay, so remember that. So okay, so let's see you in the next lecture. Okay, until then, bye.